Okay, our lesson today will be inequalities involving absolute values. Okay, we have seen equations involving absolute values, therefore these are similar to that. So let's start with the simplest one. If I have a absolute value of x is greater than 4. Absolute value of x is greater than 4. So if I see these numbers here, we said absolute value is always positive answer. If I have greater than 4, if I have like absolute value of 5 is 5. If I have absolute value of negative 5 is 5. So 5 is greater than 4, 5 is greater than 4. So these answers both are valid answers. So how do I write the answer for this one here? Therefore 5 is greater than 4. So my number should be always x must be, so my solution is x must be greater than 4 or x can be less than negative 4 because negative 5 is less than negative 4. So I just take the opposite of this number here. X greater than 4 or x is less than minus 4. So whenever we have the greater, it's always related to or. So I can be rich or poor. So I can be one of them, it's okay. If one is false, it's okay. So or, one of them can be false, it's greater is always related to or. So on a number line, solution number line, what we have is, we have 0 here, we have 4 here, we have negative 4 here. So my answer is greater than 4. X is greater than 4, which is it's greater than 4. It's not inclusive. An arrow. This is an arrow. The whole thing. So this is my solution. This means not inclusive. If I have this, it's inclusive. So in this case, it's greater than 4, but not including 4. Less than minus 4, not including minus 4. Okay, so let's see B. If I have the other one less than 4, less than or equal to 4, it's the same for less or less than or equal to. So less than or equal to 4, I can say a number like, let's take a number less than 4, which is 3. Absolute value of 3 is 3. Let's take a number less than negative 4, like greater than negative 4, negative 3. Absolute value of negative 3 is 3. So where are these 3 and negative 3? They are in between 4 and negative 4. Therefore, whenever I have less, I always say x should be less than or equal to 3, 4, and x must be greater than or equal to negative 3. This is and, they are related. So it must do the same condition here, x less than 4, and it must be greater than minus 3. Or in this case, we can write it as compact form. Negative 4 is less than or equal to x is less than or equal to 4. These two are the same. They're same. I can write it this way, negative 4 less than or equal to x or less than or equal to 4. So greater is or less than is always related to and. So this case is, I cannot be poor and rich at the same time. So if one is false, it's false. it cannot be both of it at the same time. So therefore it has to be compact in between. Okay, so let's see more examples here. So the solution for this will be on number line. Okay, if this is -4, this is 4, it's inclusive or equal to, therefore this is my solution. This is my solution. Okay, let's see. Absolute value of 3x minus 4 greater than or equal to 5. So, as we have seen before, the first one we copy it as it is. The first one we copy as it is. 3x minus 4, I write it as it is, greater than or equal to 5. And I solve this one here. 3x greater than or equal to 9. X is greater than or equal to 3. For the second one, I have to write, this is 3x minus 5 greater than or equal to 5. Because it's greater, we say or 3x minus 4, the left side I copy as it is less than or equal to the opposite sign. So 3x, when I see this, I write 3x minus 4, I copy as it is, or 3x minus 4 less than or equal to minus 5. So I copy here, or I solve this one here, less than or equal to -5 plus 4 is -1. X is less than or equal to -1/3. On the number line, my solution will be if this is x is greater than 3. If this is 3, it's inclusive. This will be my solution. This is 0. If this is -1/3, it is inclusive. This will be my solution. So whenever it is greater, there are two branches, this side and this side. Let's do more. Absolute value of 4x minus 1 less than 7. So it is less. Less is and. 4x minus 1 less than 7 and 4x minus 1 greater than -7. So remember, when it is less, we do less than this 7 and it must be greater than the negative. Just try to understand these two examples here. So 4x less than 8, and then x is less than 8 divided by 4, 2, and 4x greater than -7 plus 1, -6. X is greater than -6/4. X greater than -3/2. In this case, we have this is 0, this is 2, this is -3/2. So I have in between -3/2 and then in between. Less is always in between. This is my solution here. This question here can be solved also this way here, or I can write it this way, or I can do compact form. To do compact form, I start with the negative one. Negative 7 less than 4x minus 1 less than 7. This is the same as the whole thing here. So since there are no x's here, I can bring this negative 1 to the other sides. So I will add 1 here, I will add 1 to this one. So negative 7 plus 1 less than 4x less than 7 plus 1. Negative 6 less than 4x less than 8. I divide all by 4. So this will be negative 6 over 4 less than x less than 8 over 4. Which means negative 3 over 2 less than x less than 2, which is the same answer as this one. The number line will be, this is 0, this will be 2, this will be negative 3 over 2. It's not inclusive, not inclusive. So it's the same answer as this one here. So I can write it this way, or I can write it this way, whichever convenient for you. Okay, so let's see the last one as logical question. Absolute value of x is less than negative 8. Absolute value is always positive, so how can it be less than a negative number? Therefore, it's not logical, and we say there is no solution. Okay, so that would be it for inequalities with absolute values.